Okay, so to bring you guys back to our online, we just solved all this thing out and did all the work. I'm assuming you guys all did the work yourself before turning on this section, and you should have gotten x equals -4 or -1. You guys at home, if you didn't, go back, hit pause on the video, check your work again, and figure out your algebra mistake. Okay? But we're going to do a couple more just for fun to get some more practice. So, let's see. Let's jump to a different color. Suppose we have, that was broken. Try this one. There we go. 2x squared plus 5x minus 3 equals 0. We want to solve that. First step to a quadratic is always what? Set it equal to 0, correct? In this case, it's already set to 0, so we're good. Now, quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So substitute in. -5 plus or minus the square root of 5 squared minus 4 times a, which is 2, times c, which is -3. Make sure you put the sign in there. All over 2 times a, which is still 2. Now do the math out. Let's see, this becomes -5 plus or minus the square root. 5 squared is 25. -4 times 2 times -3. -4 times 2 is -8. -8 times -3 is positive 24. All over 2 times 2, which is 4. What's 25 plus 24?
29.
49, correct?
49.
Yeah.
Which means I was going out of my way to get an irrational solution, and this is still going to work out and be nice. But whatever. -5 plus or minus the square root of 49 all over 4. What's the square root of 49? 7. So this becomes -5 plus or minus 7 over 4, which then gives rise to two solutions. -5 plus 7 over 4, -5 minus 7 over 4. -5 plus 7 is 7 minus 5, which is 2 over 4, which is a half. -5 minus 7 is -12 over 4, which is -3. And there's my two solutions, 1/2 and -3. Pretty straightforward? You should generally check your work. I'm not really taking the time in class to check these things out. How would you check them?
Substitute the answers in.
Plug both of those x's into this original equation and see if they both work. And just so we're clear, because in the past there actually has been confusion, that does not mean you make this one -3 and that one 1/2. You're all aware it means you make both of them -3 and solve it out and get 0, and then plug in 1/2 for both of them and get 0, and then it works, correct? Good, okay. Well then let's see, maybe one or two more. And then we move on to other fun quadratic things. Suppose we have x squared plus x plus 3 equals 0. Oh, and just deliberately to change this, suppose it's x squared minus x equals -3. Just so we can complete. You're all aware, in order to solve a quadratic, what's the first thing you always have to do? Set it equal to 0. Which means for any problem you solve, for now and for the entire rest of the semester, when we see tons and tons and tons and tons and tons of quadratics, and I say, what do we do to solve this? The first thing you always do as soon as you see a quadratic term is do what? Set it to 0. So you will not create your own math to try to solve them once we get into the next chapter and we're not technically doing quadratics. Correct? You will all immediately say, That's a quadratic, set it equal to 0, right? Good. So yeah, add the 3 to both sides. You get x squared minus x plus 3 equals 0. And now solve it. Let's see. A is 1, B is -1, C is 3. So we get negative b, which is -1, plus or minus the square root of -1 squared, minus 4, times a, which is 1, times c, which is 3, all over 2 times a, which is 1. I'm aware, as you're doing this out, when you know what you're doing, you can immediately cancel out these negatives and all that. I'm deliberately writing it out long form so you can see every single step. When you're doing it on your own, you can kind of shortcut it if you know what you're doing. So we get -1, which is +1, plus or minus the square root. -1 squared is +1. -4 times 1 times 3 is -12. All over 2 times 1, which is 2. Now we get 1 plus or minus the square root of 1 minus 12. What's 1 minus 12? -11. All over 2. Now what do? Are we done? And I will point out, in some algebra classes, you stop here and you say something like, no real solutions, correct? Which is great, but last section we talked about complex solutions, right? Which means all of you know how to find the complex solutions now, so we get to do that. What do?
You change that -11 square into
Yeah, we recognize when you have the square root of a negative, you can actually rewrite that as the square root of 11 times the square root of -1. The square root of -1 is I. So this becomes root 11 I. So now we can rewrite this as 1 plus or minus root 11 I over 2. Are we done?
No.
One thing that will pop up, and I'm not going to take the time on it right now, it's actually in the review section in your book, which I mentioned before, and I don't necessarily think it's a skill that's all important in this class. You can simplify these radicals down. If you can break it up as a product of two numbers, we know the square root of one of them. If you've done simplification of radicals before, you know what I'm talking about. Given that you have calculators in this class, if you don't know the square root right away, you can always just throw it into your calculator, so I'm not really concerned with that. But what's the one thing we have to do now? What type of answer am I getting? Real or complex? Complex. When you get a complex solution, your answer has to be in what? Standard form. Which means, if you're taking a test, if you're turning in homework, if you're doing any of that, if you give me this answer, it's wrong. I'm going to take off credit because that's not in standard form. Rewrite it in standard form, and you get 1 plus or minus, or sorry, 1 over 2 plus or minus the square root of 11 over 2 times I. Again, some people will leave the I next to the root 11. I'm okay with that, even though technically it should be completely separate. And now we have real number plus or minus real number times I. Get it? You don't have to write these as two separate ones, 1/2 plus root 11 over 2I, and 1/2 minus root 11 over 2I. You can just do the plus or minus thing, that's fine. Are there any questions on that? Okay, the last thing, again, I mentioned calculators. When you are solving problems, like solving a quadratic, there's a quadratic, solve it. You can leave your answer like this. Yes, it's not like x equals 7 or x equals 12. You still got the radical in there. That's fine, leave it like that. The only time you will need to solve it out with a calculator and figure out what the square root of 11 is when you're doing an application. And when you're doing an application, you need to give me a numerical answer. So get to this point, throw it into your calculator, and you'll be done. With the calculator, you won't get the I on there. It won't be complex. But so again, either, as far as quadratics goes, factor them. If they factor, solve it, done, good to go. If you're not sure about your factoring, if it doesn't factor, quadratic formula. Throw it in, get an answer. If it works out nice and neatly, good. If you end up with a radical, just leave it like that. If you end up with a complex, put it in standard form, leave it like that. When we get to applications, you can throw them into your calculator and get an answer that way. Okay? Good. Is that enough for today? No, there's a lot more to do. I wanted to see how many of you would look at the clock and be like, yes, we're leaving early. No, there's a lot more to do. Okay. Like I had said, and I will reiterate, as far as exams go, I could really care less about how you solve a problem. Unless you're like cheating or something, don't do that. But in general, as long as you're doing math and solving the problem, I'm completely fine with it. Here's a quadratic, solve it. Factor it, quadratic formula, complete the square, I don't really care. As long as you can solve the problem, you're good. But does everybody know what completing the square is? Anyone? You kind of vaguely remember doing it and you hated it when you did it? I'm not really a fan of it. It's a useful skill, and it can help you solve a lot of problems. You do not need to solve quadratics by completing the square. I'm not going to make you do that. In some algebra classes they do. I'm not, but we're going to go over it now because completing the square is actually a useful skill for a lot of the things we will be doing later in the semester. There'll be like 2 or 3 different topics we're going to cover that require completing the square. So I figure we'll go over it now since it's in this section, and then we'll probably come back to it several times throughout the semester. And hopefully by the end of the semester, you'll be good with it. Okay? Yes? Okay, good. Let me check really quickly to make sure we have enough time to get through all this. We probably don't. So I'm going to stop this and restart it again so we don't have to cut the lecture halfway through.